Hi, this is the progress report for Sprint 7. I'm going to start with the ACI since that was something you commented on. So it should all be done, and I have a lot, so I'm not going to go through all of them, but I'll just show you all the attorneys I have. So engine attorney, time attorney, scene manager, scene, texture manager, uh, shader, model, updatable, and you'll notice these are also subdivided based on what the actual accessors need. So, for example, game loop registration, inputable, game object, drawable, collision, alarmable manager, alarmable. The visualizer has an attorney, that's why that was open, but the the bSphere also has an attorney. So these are the two new ones. Visualizer just for show sphere and visualize all, because I don't want the game object to have access to those. And then the bSphere just has the compute data and the intersect. I actually wasn't sure whether this one needed one, but I decided to err on the side of caution. So with all the ACI out of the way, I can go ahead and actually show off the demo as it stands. So you can see, first of all, got the tanks textured correctly. bSpheres are appearing. This guy now moves, although for some reason when I'm moving directly backwards, he seems to have some trouble, but that's a minor issue considering every other instance he follows me fine, so I will fix that at some point, but I wanted to show. And the camera obviously also follows the tank. So with that being said, I'm going to use my God cam, which I do have, to wait for this guy to come closer, freeze, and step by step I'll let him approach me so that you can see. Not colliding, not colliding, not colliding, and eventually, bada-boom, now it is colliding. So, and you can even see that it started printing when that happened. So, the spheres stay red because currently there's no exit collision that I could use in order to make them go back to blue. But, you know, that's probably something we'll be changing in the near future, or at least at some point. So, there's my collision, and you can see that it stopped printing, by the way, so it really is done colliding, and it'll start printing again if I go back into the bSphere. Also, I'll press enter, which is my scene change command, which just takes me back to another copy of the same scene, but it's a separate class technically. And the collision still works fine, so there you go. So first I'll start with the collision volume. So you can see here that it's implemented here in Collidable with a few one-line functions to set the models and such. The actual collision volume class is just an abstract class, so nothing really going on with it. Then the bSphere, and a lot more one-line classes, but also or one-line functions it is, and also a couple that are defined here. Just gets the center and radius, multiplies the center by the entire matrix, gets just the scale vector. We're assuming uniform scaling, so I only need to check one column, and multiplies the radius by that. And then the intersect just calls to math tools. Next up, I'll talk about the visualizer real quick. So it has a few different functions for show vSphere, which is the one that is called from outside the instance. Private render sphere, which is called from show bSphere, and then does its own separate stuff. And then the visualize all just loops through, executes all the commands, and then clears. The object should send the commands once per frame. I'll show that when I get to the actual game objects themselves, and then just a delete. So that's the whole singleton and the default color and whatnot. Math tools is just the one function right now, and here it is. It's just the math we talked about in class, and then returns true or false. Next up we have the commands. So first off, self command, it just does the whole thing where it loops through. Now it actually keeps const bSpheres for each one that it checks, and then it compares them to each other through the bSphere attorney, and that does call to the bSphere intersect function and not the math tools one, just to be clear. Same with the pair command. Same exact process, really. So while I'm here, I just want to show the collision manager real quick and show that I got the new solution implemented. So the way I do it is that in the new function, I just push in a null pointer as the default value, and every time a new one is added, a new null pointer is pushed. So there should no longer be a redundant assert. Not that there's an assert at all anymore, but this is the implementations we discussed, the new implementation, that is. Okay, so let me actually go ahead and do my God cam, since I didn't do that at first. Well, I did a little bit of it, but so these are all my movements, my strafes, and my up-down. And here's the actual implementation. A lot of it's more or less the same process of just getting the information from the camera, updating that based on what key is being pressed, and then resubmitting that to the update camera. And because, as you may have noticed, if I ever move while I have the God cam on, since the tank also updates the camera, that'll reset the camera to focus on the tank. So that's not an issue with the God cam. That's just a result of how I implemented that. So last but not least, I'll look at the actual game objects and show the implementation. The bullet, it has the collision still, but because I didn't want to worry about dying and stuff while I was trying to show off the collision between the tank and the frigate, or the tank and the enemy, that is, this doesn't actually have the structure to collide yet. So the actual game object that does have collision set up is would be the tank and the enemy. So you can see they collide with each other. That's where they change the sphere command. They both also have a sphere command, and throughout the process of assembly, they will create their world matrix and use that to get a sphere, which they then pass into the sphere command. And then the sphere is also updated by the update function here. So here is the actual enemy code for how it rotates. It just takes two vectors, one on each side, and then whichever one the frigate is closest to, it'll rotate towards that side. So it's really nothing that crazy. And one last thing that I want to mention is that I know one of the things on my to-do list is the fast delete on, I think it's the inputable manager. I just want to say that I haven't forgotten about that. I just have had more important things to implement. So I will get back to that at some point, but I haven't yet.